Hello everyone. I'm Aurélie Baker. I'm working at Aerospace Valley and I'm the ESABIC Sud France manager. So today we are glad to welcome David Hello from TerraNIS. I just would like to say some more about why we are doing this webinar today. So TerraNIS is an old incubator of the ESABIC. Now it's an alumni, and we decided recently to organize some webinar to highlight our alumni, to promote what they are doing and so on. So I want to thank ESA to also promote this webinar through the ESA Space Solution Network. And thank you for visiting today. And David, I give you the floor.
Okay, thank you, Aurélie, and welcome to everybody. I'm very pleased to be there with you this afternoon to present what we do at TerraNIS. I will show you some slides for that purpose. So, Aurélie, just shout if the presentation does not appear. Okay. So the objective of this presentation is to show how we use satellite imagery in our daily business, which is centered around vegetation at large. That's why the title of the presentation is From Satellite Imagery to Agronomic Decisions. So let's start with a very short presentation of what is TerraNIS and who is TerraNIS. So we are a small company based in Toulouse suburbs that we created in 2040, so around 7 years ago. And our business is to design and to sell geoinformation services based on Earth observation and based on satellite imagery. This is our core competence, but you will see in the presentation that our core competence is not only remote sensing, but even more, I would say, agronomy, land management, environment, biology, and whatever. So we are today, let's say 18 to 19 employees based in Toulouse, but also in Chile, in Santiago. With one person based here to develop our commercial activities there, and one person located in Spain, in Madrid. While our annual turnover is in the range of 1 million euros per year. And we have customers, of course in France, but also elsewhere in Europe, and also in other countries outside Europe. Of course, in Chile, where we have one person, but also in some other locations. So we created the company 7 years ago, as I said before, with the support, and I want to take this opportunity again to give a warm thank you to the Aerospace Valley and to ESABIC Sud France. They really supported us at the early stages of the development of TerraNIS. So thanks again for all what you did for us. And since this date, we have tried to develop our activities in 3 segments. And I will give in my presentation some examples of what we do in these 3 segments. The first one is related to the wine growing sector, to vineyards, the monitoring of vineyards, with one service which is called EunoView, that I will present later on. Then we've got activities in the agriculture and forestry domain with several services that, again, I will present later on. And last but not least, we have also a service offer in the segment of environment, which is a bit vague, I admit that. But I can say that we deliver services for decision makers at territory level, in order for them to define and to monitor land management policies, for instance. And I will give you an example with the Green City service in the coming slides. So 3 segments, All of them, of course, where we are using satellite imagery. Again, this is one of our core competence, but not only. We are using other data sources, other pixels, I would say, coming from other sources. So in some cases, coming from airplanes or from drones, but also data coming from in situ sensors, for instance, or from models. But again, I will give some examples later on. So let's go ahead with the three segments and with some illustrations of what we do precisely. So first of all, let's start with the overview service, which is twofold, actually, twofold. There is, first of all, overview premium, which is a service dedicated to the optimization of the harvest. It's a service that allows the wine growers to get a very accurate view and, well, let's say, complete view of the exploitation of all the vineyards, in order for him to optimize the sampling that he's doing few weeks before the harvest, to segment his domain, and also, for instance, to define batches of homogeneous grapes that will give later on high quality wines. The purpose of an overview premium is really to increase the quality of the wine at the end and the quality of the grapes, and also to increase the volume of grapes that can be harvested. So this is the first application with some examples here of maps where you see, well, basically the vigor of the vegetation, so of the grapes, a few weeks before the harvest. And why is it useful? Well, when we originally developed that service, we have proved that if you got an accurate view of the vine vigor few weeks before the harvest at a stage of the development of the vegetation, which is called the véraison, which is a French word, which corresponds to a stage of the vine where the sugar begins to appear. And if you acquire some images at that date, what you see at that date can be very well correlated with what will be the grapes when you will harvest them few weeks after. So this is the first service. The second one, which is called an overview Ferti, which is more dedicated to the optimization of the fertilization. So I don't think there is it's no need to really explain in detail, but the objective is to adjust the quantity of fertilizers that you put in the field, so the right quantity at the right time and at the right location. The objective, of course, being to reduce the cost of the fertilization and to optimize the use of the fertilization, and of course, it's a consequence to decrease your impact on the environment. So this is the overview 30. And to illustrate better what we can do with satellite imagery and vineyards, here is an example of a plot, a field in a vineyard, where you see the vigor of the vine, and you see that there are heterogeneities in this particular case. You see green zones, you see orange zones, and the more reddish ones, and also gray zones. According to the color that you see there, which correspond actually to something which is called the green cover fraction, which is more elaborated than the well-known NDVI index. So the green cover fraction is much more complicated to calculate, but much more accurate and robust, because you can compare between two dates things which are similar. So with this green cover fraction, you have these different zones, different colors. And in the case of vineyards, you have here some examples of a green zone, which is a vigorous zone where you can find compact grapes, numerous clusters, and which will give at the end herbal flavors and rough and astringent wine. So which can be one objective of the wine grower, clearly for some specific types of wines. Conversely, the orange and red zones show moderate vigor. And here you will have more fruital flavors and a different kind of wine. And in the last but not least zone, the gray one, here clearly you've got problems. There are maybe some missing vines. There are maybe problems of disease in the countries and in the regions where irrigation is allowed. Maybe there is a problem with the irrigation. And to know that, there is no magic things here. You need to go in the field. I mean, from the from above, from the satellite, you cannot guess exactly what's happening. And this is something on which I want to insist, because I mean, producing nice maps and processing pixels and so on is really interesting. But at the end, the objective is really to give to the wine grower some agronomic advices, and this can be done only if you can cross this information with some other information coming from the field. And this is why for all our services, we always rely on someone, a local, let's say, expert, who can make the link between what we see from above and what's happening really in the field. And that's really important. And I would say even more that it's absolutely mandatory if you want to deliver a high quality service to your customers. This slide is another, let's say, illustration of what I just said before. So imagine that you've got here plots where you grow red grapes. According to the level of vigor, you will be able to decide what is the best wine you can do with this specific field. So, for instance, if you start from the left, you've got, let's say, a quite vigorous plot, but also very heterogeneous. And with this kind of grapes, it's, let's say, more than likely that you will be able to produce some good rosé wine. On the other side, let's go to the right-hand side of the slide. You've got moderated vigor, okay, but which is not always bad news, and I would even say sometimes it's good news. And in this case, it's moderated vigor with a good homogeneity. And clearly, for red grapes, this is with this kind of fields, and that you will produce the highest quality, fully bodied red wine. And in the middle, you've got other examples for fruity red wine or another high quality red wine, but for late harvest, because in that case it's homogeneous but high vigor. So it means that you will have to wait a little bit more to harvest this specific plot. So this is to illustrate what we can see from above. And this is, well, a simplified process of what we do practically with our customers. So first of all, we need to get from the customers some input data, for instance, the contours of the field, and some information about the vineyard itself. So the distance between two rows, the orientation of the rows, if there is herb between the rows and whatever. Using this input data, knowing this input data, we program satellites in order to get the appropriate images at the right time for the right location, of course. So it means that we, in that particular case of the ONUVIEW service, we use commercial satellite imagery, and in that case coming from Airbus with Spot 6 and Spot 7 images, which are acquired at Veraison, as I said before. When I say at Veraison, it means that we've got a target window of, let's say, 5 to 10 days maximum between the Veraison to acquire images which are really useful and which will give the best results after all. Then we produce all those pixels and we generate different maps, products, Excel sheets giving statistics, PDF files, of course, but also for each plot, for each field. I did not mention that before, but the information we deliver is for each plot. And also we deliver the information on your mobile device using a dedicated application with which you can go in the field even without an internet connection. You can download the information in your device, before going into the field, and then in the field really confrontate what you see from the images and what you see in the field and annotate the images so that when you go back to your office, you can really make good decisions. So this is how ALUMNI is working. Let's go ahead with the services for agriculture. So what is the difference when you would say that wine growing is also agriculture? That's right. Agriculture in that particular case means, let's say, large crops, corn, wheat, rapeseed, and so on. So for this kind of crops, we've got specific services, 4 services, namely, so Pixary, Cropio, Fertiliser, and Wago, that I will present in the coming slides. Again, all are using satellite imagery, but in that case, for the 4 services that we have here, we are using Copernicus data coming from the Copernicus program, European program, Copernicus, with the Sentinel satellites. Both Sentinel-2 and Sentinel-1, but clearly more Sentinel-2 than Sentinel-1. What are we talking about? So let's start with Pixary. So with Pixary, it's a quite simple service, and to be very honest with you, it's now, let's say, a quite old service, and we are currently reshuffling and revamping completely this service because it's today delivering very good data, very good information, but not sufficient compared to what is now available in the market. Anyway, with Pixary, we are able to deliver vigor maps of a lot of different crops using satellite imagery with a resolution, from 1.5 meter in some specific cases, but generally more 10 meters or 20 meters. Again, here, what we do is we calculate biophysical parameters, which are specific to each crop. And again, this is a big difference compared to other solutions. So using vegetation indexes, we do not use with Pixary vegetation indexes, but biophysical parameters such as the vigor, but also what we call LIE, so leaf area index. The quantity of chlorophyll is also something that we can calculate using the Sentinel-2 data. The objective of those vigor maps is to provide the farmers with a good view of, again, the heterogeneity of each parcel, but also the heterogeneity between different parcels. And the objective at the end is, again, to save inputs, so what you put in the field to grow the vegetation, so fertilization, irrigation, and so on. And it's a tool, it's a decision-making tool which complements the expertise of the farmer, again, to make the best decisions from an agronomic point of view. Then we've got the Fertiliser product, which is more dedicated for the calculation of the nitrogen level needed to optimize the crop growth. So the system is, I would say, quite simple. We acquire an image at a certain date. We calculate what is called the INN, so the nitrogen level of the vegetation, which gives the opportunity to the farmer to define the right quantity of fertilizer he should put in his field. And when I say the right quantity, it's a relative quantity. So with the fertilizer service, the farmer knows in which part of the field he should put more fertilizers and in which part of the field he should put less fertilizers. But we do not give him the precise quantity of fertilizer he has to put. It's a relative indication. And after he has made the fertilization, we provide another image which shows, hopefully, that the field is more homogeneous, which is really what is expected. Sorry. Then we've got the Wago service, which is a brand new one, which has been developed in a partnership with the CESBio laboratory here in Toulouse, which is, to be more precise, a technical transfer of the CESBio to TerraNIS. This Wago service is dedicated to the monitoring of the irrigation, and more precisely, it's an online tool which allows the farmer to calculate a daily water balance, to assess the crop water needs, and to again be more efficient in the crop growth of this field. What is important to say with the Wago, of course, again, we are using satellite imagery, and here we are using Sentinel-2 imagery, but we are also using weather forecasts, weather observations, and all these to feed a model. So this is something quite new at TerraNIS. It's not a pure remote sensing service. It's really mixing remote sensing, modeling, and in situ data. At the end, the farmer knows if there is stress for its crop, and we even give him at the end a quantity of water he has to put in which field and when. And this information is given through a web interface, but also through a mobile application, again, with some snapshots here. Then we've got the Cropio service, which is also a brand new one, not fully industrialized, to be fully transparent. The objective of this Cropio service is to detect, as soon as they appear, abnormal agronomic situations in the field. So it means that with this Cropio service, we acquire continuously all the Sentinel-2 and Sentinel-1 images that are available for specific fields. We do analyze in real time what is the profile of the development of the vegetation, and we are then able to detect which field seems to have an abnormal development compared to other fields, or to compare the development of this field with the same field but in the previous years. So the objective here is, again, not to let's say there is no magic things here. We are not yet able to say precisely what's going on, why is there an abnormal situation, but at least we are able to detect as soon as this abnormal situation appears that well, there is something to do in the field. I would say that in parallel with the development of this commercial service, we've got a thesis which is currently in progress, where we using the same data, we are using artificial intelligence, not only to detect these abnormal development situations, but also to try to guess what's going on. And this is something very promising, and hopefully we will be able to deliver this kind of service in the coming, let's say, 1.5 years or 2 years. Then, well, I finished with the wine growing sector and agriculture, and I will finish with what we do for the environment and land management. And I said at the beginning that in this segment, we are developing solutions for decision makers, such as the mayor of your city, or let's say the president of the region, or whatever. The objective is to again provide indicators which allow these decision makers to make the good decisions. Let's say upstream, when they have to define land management policies due to, let's say, European directives, for instance, or any other local directive, but also for the well-being of their citizens, not only because of legal constraints. So define the policies, monitor the policies, and see the impact of those policies after weeks, months, and years. The example I'm giving here is the Green City service that we have developed in the past, let's say, 4 years, actually, and which is fully operational since last year, and that we started to sell last year to some municipalities in France and also in Europe. Green City, what is that? It's an observatory of green spaces in cities. To build this observatory, we are using Earth observation data, but also a lot of open data coming from the territories themselves. So today we know that there is a lot of open data available. So you've got, for instance, statistics about the citizens. You've got statistics about also the trees that you have planted in the cities and whatever. So we cross the information that we gather from Earth observation with this open data or data coming from the territories. The objective is to visualize, analyze, and manage urban vegetation, in a simple way. We really had in mind since the beginning that this kind of tool may be used not only by professionals and technicians, but also really by people who do not have the technical background or in GIS, remote sensing, or whatever, but who want to make good decisions. What we are working on today is based on this data related to the vegetation, is to optimize the well-being and the biodiversity at the level of a municipality or a group of municipalities, metropolis, or a region. The images at the bottom of these slides are very important because it shows what is overall the process that we are using with Green City. We start with raw products, so satellite imagery, for instance. From these raw products, we process data to get more value-added products that we cross with other information. This is the second bullet. In the third bullet, we produce indicators at different scales. For instance, here with hexagons, which is something really interesting to compare areas between inside the same city, for instance. And last but not least, on the right-hand side, we produce dashboards which are really dedicated to decision makers and which hide all the complexity of the process upstream and gives really information that can be understood easily and used very easily. Here are some examples of these dashboards. So you've got here the Green City that we have produced over our city, Toulouse, showing the vegetation, the level of vegetation using these hexagons that I talked about before, or at the level of areas which are called quartiers in French. And on the right-hand side, you've got the numerical indicators with which you can play. You can select a zone in your city to see what is the level of, for instance, the area of vegetation in this area, what is the area of canopy per inhabitant in this area, what is the area of public green area per inhabitant in that zone, and so on. And you can compare what you've got in this specific area with the average, or the average, let's say, of the other areas in the same region or same city. How is it used by decision makers? So, of course, as I said before, to support political decisions and evaluations. So we've got some in France, but at European level, it's the same. You can work on green and blue corridors. You can work on biodiversity. And you can use that tool also to communicate towards your citizens, which is also something which is really important nowadays. Here you've got an example of another screen, another tab that we've got in the Green City, which uses the Street View, Google Street View images, which are processed in order to calculate the vegetation index, but at the level of a human being, not from above, but from the soil, which is really interesting because with satellite imagery, you see what's happening from above. But with this kind of view, you see, as a pedestrian, for instance, the quantity of vegetation that you see around you, 360 degrees around you in the street. So this is something which is really appreciated also. And here we've got another example that we have worked on for the Cape Town in South Africa, where we have used satellite imagery, but also DEM products in order to discriminate, I would say, not only vegetation, but the height of the vegetation and the height of the canopy. And last example, which is derived from satellite imagery, which is also something very requested nowadays by decision makers in cities and metropolis. We are able to detect and monitor high surface temperatures area in the cities using thermal infrared images. This information can be, with some additional processes that I do not mention here, but that we also use, to isolate what is called island heat areas in cities, which is something very important for the well-being of citizens, and which has a real impact on the greenhouse gas emissions at the end. And I think I've finished with all my examples. So, well, as you can see, again, we are using satellite imagery and products coming from space programs such as the Copernicus program, because not only satellite imagery, but also value-added products. We are using a lot of open data. We are using in-situ data. We are using models. And we are using the expertise of our own agronomists, land managers, biologists, and so on to, at the end, mix all these to provide really decision-making tools to people who are not familiar with remote sensing and whatever. The objective is really not to deliver maps, but really to deliver value-added information. Thank you for your attention. And if you have questions, feel free.
Thank you very much, David, for this very interesting presentation. So you can ask your question through the chat. So we have already one. David, in which crops did you test Wago and Cropio?
So for Wago, today it's fully operational for corn. but it has been designed to originally by the CESBio laboratory to manage other crops. There is a list. So of course wheat, but also cotton, whatever. But today we are targeting corn because it's one of the most interesting crop for the irrigation management, because it's as you all know, corn is irrigated everywhere, and as maybe you don't know, it goes really in the other. Well, people think that corn is using a lot of water. No, corn is one of the crop which is using the less water, but unfortunately, it uses water in a season where water resources are scarce, so during summer. So this is why it is important to manage the irrigation of corn. And Cropio, also corn, but also wheat, rapeseed are the main crops on which we are working. But we have also made some, let's say, tests related to Cropio with some vegetables also. I hope it answers the question.
Okay, so we have another question. Does you have a minimal parcel size for analysis, especially with satellite data at 10-meter resolutions?
Very good point, indeed. And it's even more true as soon as we are talking about vineyards, because I said that we are using spot imagery for vineyards, but we are starting to use also Sentinel-2 imagery for vineyards because it's really interesting. But the drawback is that indeed parcels which are I would say, to simplify, less than half an hectare are well, you don't have good results. I mean, that's clear. I would say that parcels bigger than 1 hectare, it's okay. For crops such as corn and wheat and so on, that's very easy. For vineyards, it's not that easy because in some regions, such as in Burgundy, I mean, you've got very small fields, and in that case, Sentinel-2 is not appropriate.
So I have another question. Does orientation of rows in Vineyard affect the precision of your vegetation analysis?
Sorry, can you repeat, Aurélie? I didn't catch.
Yes. Does orientation of rows in a vineyard affect the precision of your vegetation analysis?
The orientation of the, sorry.
The orientation of row.
Orientation of rows. Okay.
Yeah,
okay.
sorry for my accent.
No. Two French people talking English with a bad accent. Sorry. No, the orientation has no impact as soon as we are using high resolution imagery. The impact is more on the distance between rows, and if there is air between the rows. And this is a real issue to tackle, but we have solutions to tackle that, but that's a real issue. I mean, the worst case is to have vineyards with a big distance between rows and vegetation between the rows, because in that case, of course, what you monitor is not the vine, but the air between the vine. Okay, so but this is something that for which we have solutions. But if you allow me not to say more, because this is something where we have, let's say, some competitive advantages.
I have another question. Beside high density crops and canopy vineyard, did you test it in orchid system like apples?
Haha, good point. Well, actually, when I'm talking about our three segments, the first one being wine growing, I should say that this first segment is internally at TerraNIS called viticulture and perennial crops. Because perennial crops such as fruits, for instance, is something of big interest for us. I wouldn't say apples, but more almonds, for instance. And yes, we are working on that. There is no commercial service for that at TerraNIS, but I can tell you that we are working on that because almonds, for instance, are very high value crops where we are convinced that our technology can bring a really added value. Well, the answer is yes, but no commercial service yet.
Good question. So the question is, I would be interested to know which are the specific cases where you use radar data as vegetable regrowth, clouds, not a strong limitation for optical data.
Yes, that's why. Exactly. That's the point. As soon as, well, I would say two things. First of all, if you need to acquire an image at a specific date with a time window of 5 to 10 days, and if you use commercial satellites, you have very high probability to get the right image because the commercial satellites are agile. They do not capture image just below them, but they can turn on themselves in the 4 directions. And then you've got good opportunities to, even if there are clouds, I'm not talking about clouds which cover 100% of the sky during 1 month, of course, but with this kind of agile satellites, you've got a good opportunity to capture the good image at the right time. And we experienced that with the ALUMNI service, where we are able, in particular, because it is in the summer period, we have very few cases where we cannot get the appropriate image. When you are using satellites such as Sentinel-2 or Sentinel-1, well, I would talk about Sentinel-2. The satellite passes, it's not agile, but it has other very good, let's say, properties. But it's not agile. So you are indeed blocked by clouds more often. This is why whenever you want to analyze the temporal behavior of a crop every week, let's say, you may have dates where you cannot acquire images, and in that case, using Sentinel-1 in addition, because it's radar imagery that is not blocked by clouds. And this is precisely what we are working on in the thesis I mentioned before, and you really get good results that allow you to fill the gaps between 2 dates when you do not have optical imagery. And I would even say that even if you've got optical imagery, adding the information coming from the radar brings value.
So another one. Can Wago be applied to vineyards? If not, do you plan to develop a tool to do this?
Only good questions. Well, Wago today does not work for vineyards. That's clear because, as I said before, the kind of canopy of cover vegetation is really not the same, and the model behind does not work. But we are working on it. We've got a project, believe it or not, but funded by ESA, where we are working on this adaptation of Wago to vineyard monitoring. But it's not. It's not a piece of cake. The job is not done.
Okay, another one. Do you use angles for vineyard observation? Which distance for pixels?
Can you repeat?
Yeah. Do you use angles for vineyard observations? Which distance for pixels?
Sorry, I do not understand the question, but it's not your English, Aurélie. So I don't understand the question.
So, I will not try to pronounce the your name. So if you can maybe precise your question.
Yeah.
Ah. Or maybe it's Atijana. I'm not sure. I have to say. So maybe we write. You have some precision question. Yeah.
Maybe Aurélie, if you got the question afterwards, send it to me by email and I'll try to answer. By the way.
Yeah. Okay. So, other questions? So in any case, you have the David emails on the slide, and if you have any question, I think you can contact him. And we will post on our social media the replay of this webinar. So thank you, David, for your presentation. Thank you, everyone, for listening today. So I think we can maybe we can conclude.
Thank you, Aurélie. Thank you to ESABIC and to Aerospace Valley again for all your support in those years.
You're welcome. So, pleasure.
Good.
Okay, thank you.
Bye-bye. Bye.